Well, okay. So the question becomes, how do we compare one data point with another data point? And the funny thing is, you already know the answer because you've been doing this your whole adolescent life. You've been taking standardized tests. So what does that mean? Standardize. When we standardize something, that means we make it all the same. In other words, standardized tests allow us to compare kids in Hawaii to kids in New York, to kids in Germany, to kids in Japan, right? They all take a same test. And in theory, they have standard scores, right? Because, the reality is sometimes an 82 in Hawaii is different than an 82 in New York. But if we have them take a standardized test, then we have a way to compare values. So standardized tests to standardize data means to put everything in terms of deviations from the mean or in terms of a percentile. And these are the two things we're going to talk about. 1, 2. Deviations from the mean or percentile. And that's it. That is totally it. Okay? Now, what do those two things mean? That's why we're here today. Okay? Let's start with percentile. Now, if you did your reading, you know the percentile is the percentage at or below a given data point. Now, some textbooks leave out the at or. Some leave it in. I leave it in. The more data you have, the less difference there is between below and at or below. But if you think about it, if you have 10 scores, 72, 75, 77, 80, 82, 85, 88, 90, 70. We'll go with this end. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's take 85. Now think about that. I mean, I'm showing you this with an example because this is basically how you learn statistics. If you use the definition below the given data point, 85 would be the 1, 2, 3, 4, 5, 6. There's 6 out of 10 below this, right? So it could be the 60th percentile. If you do at or below, 1, 2, 3, 4, 5, 6, 7, the 70th percentile. So there's a bit of a difference, and the difference is more exaggerated the smaller amount of data you have. So we say that 85 is we're going to say 70th percentile. Now, what does that mean? That means that 70% of the scores are at or below. Now, if you read a textbook, and maybe if you read your textbook, it says simply the percentage of data below the point. And if this were 1,000 scores, it wouldn't matter, right? If that were 1,000 scores. And so that's what that means. But for the smaller the data, we say at or below. And you will never be asked to distinguish between at or below or below. That's the percentile. So when you get your little standardized test scores back, you've seen that, right? You scored in the 86th percentile. That's out of millions of kids. So what does that mean? That means you scored at or better than 86% of the kids. And if it's a whole lot of kids, like in the case of these ACTs and SATs, it simply means you scored better than 86% of the kids. And not as good as 14% of the kids. That's what percentile means. This is not a deep thought here. But that's one way we can compare average height with points scored in a basketball game, right? Right? We use percentiles. You could be in the 85th percentile for height, which means you are taller than 85% of the kids, or you could be 85% in scoring, which means you score more than 85% of the kids. Okay? That's how this works, percentile. The other way we talk about this is with deviations from the mean. Let me show you an example. Let's say the average height X bar is average, remember that, is say 64 inches, 5'4". I think that's the average height for adult women. Let's say we've got a standard deviation of 1.5 inches. And I may have an X value of 67 inches. Now, here's the thing. The 67 in and of itself doesn't really mean anything. Right? That's what we call the raw score. Maybe you've heard that before with your SATs and things like that, the raw score. Tell me about the location of 67 compared to the mean 64. How far is 67 from 64? 3. How many standard deviations is that? 2. Right? Right? Because what does this say right here? This says, look, the average height for adult women is 64 inches with a standard deviation of 1.5. That means if you pick any random adult woman, she's going to be on an average 1.5 inches away from 64. Let me repeat that. This means that if you choose a random adult woman, on average, she will be 1.5 inches away from 64. Let's say you chose this random adult woman at 67 inches. She's 3 inches away. That's 2 standard deviations. So we say 67 minus 64 divided by 1.5 equals 2. Or in general, and here's the big formula of the day, we say Z equals data point minus the mean divided by the standard deviation, where Z is what we call the Z score or the standardized score, the standardized value. So the next time someone says to you, how many goals did you score in your soccer game? You don't say 3, you say 1.5. And they'll say, what? And you say, I scored 1.5 standard deviations above my mean. When I look at one of the teacher's geometry scores, I don't want to know the kid's got an 82 or a 76 or an 83. I want to know how many standard deviations was any kid away from the mean. So if I say to you, kid, hey, how'd you do on your chemistry test? And you say 78, I'm like, okay, well, what does that mean? Maybe it's a great, at our school, 78, it's a horrible score, but when you get to college, if you get a 78 on your first chemistry test, that'll be an A, I guarantee you. Why? because it depends on what the average and standard deviation are. So the 78 is not meaningful. But if you said, I got a plus 2.5, that means you're 2.5 standard deviations above the mean. Woo-hoo. All right, what if you score below the mean? Let's test here. Let's say I've got another x, we'll call that x1. All right, same scenario. X bar 64, standard deviation 1.5. Let's say this x2 now is 60. Again, what does 60 mean? It means something if you know the mean and standard deviation. So here's what we say. We say 60 minus 64 over 1.5. So that's 4 over 1.5. So what's that? 4 over 3 halves, which is 8/3. So that's like 2 2/3, right? 2.6 repeating. So what does that mean? Actually, it's a negative. Negative. That means you were negative 2.6 repeating standard deviations away from the mean. Now, be careful with your words there. You don't want to say you were negative 2.6 below the mean. That would be a double negative. But you're negative 2.6. That means you're below the mean by how much? 2.67 standard deviations. Now, in the next section, right, watch that when you were talking about that video, we'll see exactly how far this is away. What does this mean? Is this good or bad? But right now, I just want you to be able to calculate the number of standard deviations you are away from the mean. Are we clear? So let me give you another example. I'm a terrible golfer, right? Mr. Ulrich is a great golfer, right? His average is about a 75, and he probably has a standard deviation of 2. So if he shoots an 80, right, he's 2.5 standard deviations. You know, that's above, but in golf it means below. So he's 2.5 standard deviations away from his mean in a bad way. Are we clear on that? If I shoot an 80, which I never have in my life, right, my average is about a 92 with a standard deviation of 6. I'm 2 standard deviations better than my mean. So an 80, if you say, oh, what'd you shoot, Mr. Ulrich? You say, oh, I shot an 80. If you say, oh, what'd you shoot, Mr. Griffith? I shot an 80! Right? Does that make sense to you? The 80 in and of itself doesn't mean anything. But it's the number of standard deviations away from the mean that means something. That's what this is about. The number of standard deviations away from the mean. And for your life right now, this is your formula. You have to have that. Now, you don't have to memorize it. I'll give it to you at the top of every test, but you've got to know how to use it. You're going to use this for the rest of the course. You'll use that formula right there. All right? Standard deviations. An 80 doesn't mean anything, but the number of standard deviations away from the mean means everything.